Let us see the speed. Distance traveled by the moving object in unit time period or unit interval of time period is called speed. Speed is a scalar quantity. S for scalar, S for speed. Speed is a scalar quantity. Speed, it is defined as distance by time. Speed is equal to distance by time. CGS unit to express the speed is centimeter per second. SI unit meter per second. Speedometer used to measure the speed of the vehicle. It is the scalar quantity. These are few words for speed. And also we have the one more information here. Average speed. What is average speed? Average speed. How to define the average speed? Total distance traveled by an object to total distance by total time that is called average speed. What is uniform speed? A, B, C, D, E, F, G, H, etc. are the different positions. Distance in between A to B is X, B to C is X, X, X. Distance is same. If object covers the equal distances in equal interval of time period, for example, it is takes 2 minutes, 2 minutes, 2 minutes, 2 minutes, 2 minutes, 2 minutes. Object covers the equal distances in equal time period. That kind of speed is called uniform speed. Non-uniform speed. What is non-uniform speed? If an object travels equal distances X, 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 distances are same. Yes. These equal distances are covered in unequal interval of time period. 2 minutes, 3 minutes, 1.5 minutes, 4 minutes, 3.5 minutes, 2.8 minutes. What happens here? Equal distances covered by an object in an unequal interval of time period, that is called non-uniform speed. And also it is expressed like this also. A, B, C, D, E, F. Here distance is X. Here distance is Y. Here distance is Z. Distance is U. Distance is W. So unequal distances are covered in equal interval of time period. So object either cover in equal distances and unequal interval of time period, or unequal distances in equal time period, that is called as non-uniform speed. Next, velocity. It is represented with V bar. Velocity of a moving object is defined as the displacement of the object in unit time of interval. In unit time of interval, displacement by unit time of interval, that is called velocity. Velocity is equal displacement by time. Its CGS unit, displacement unit centimeter per second, SI unit meter per second. Velocity, it is a vector quantity and its SI unit is meter per second. Velocities also, different types of velocities are there. One more thing here, instantaneous speed is there. What is instantaneous speed? Instantaneous speed, it is defined as the speed of an object particular time and particular position. For example, object is traveling like this. Yes, at this point, at C, we want to determine the speed. So how to measure the speed? Speed of the vehicle measured by the speed gun. Speed gun, it is used to detect or determine the or measure the speed of the vehicle in a particular interval of time period. So police officers generally give the objections on overspeed, how to detect the overspeed of the vehicle and give the fine for that person. As for the instantaneous speed, police officers will give the fine for the persons who are traveling with overspeed. That is, this is the instantaneous speed. Velocity. Same here also. Average velocity. What is the average velocity? Total displacement by total time period is called as average velocity. Uniform velocity. What is uniform velocity? If an object traveling equal distances in equal interval of time period, that is called uniform velocity. Equal distances covers the equal displacement, that is called uniform velocity. If an object travels unequal displacements in equal interval of time period, similar, it is very similar to speed only. If an object displaces from one object to another, one position to another position in equal interval of time period in equal displacement, that is uniform velocity. If object moving or displaces unequal distances in equal time period or equal displacements in unequal interval of time period, that is also called non-uniform velocity. Instantaneous velocity. In a particular time period, velocity of the object is called instantaneous velocity. Like this, we have the different types of velocities. Uniform motion and non-uniform motion. When an object travels equal distances in equal intervals of time, the motion of the object is said to be uniform motion. Suppose a car covers 60 kilometer in first hour, another 60 kilometer also in second hour, so on. The motion of the car is uniform. Non-uniform. When an object travels unequal distances in equal intervals of time period, the motion of the object said to be non-uniform. Motion of a car on a crowded street, a person is jogging in a park, etc. These are called non-uniform motion. ఇప్పుడు ట్రాఫిక్లో ఉన్నామనుకోండి, ఎలా వెళ్తాము? స్లోగా వెళ్తాం. జాగింగ్ చేసేటప్పుడు కూడా అక్కడ అందరు కూడా ఉంటారు కాబట్టి స్లో మూవింగ్ ఉంటుంది. కాబట్టి దీస్ ఆర్ ద నాన్ యూనిఫామ్ మోషన్స్, రైట్. Acceleration. What is acceleration? A bar. What is acceleration? Already we know. Acceleration, it is defined as the rate of change of velocity. Rate of change of velocity is called as acceleration. Its CGS unit, centimeter per second square. SI unit, meter per second square. It is a vector quantity. Accelerator is used to measure the acceleration of the body. Acceleration of the body measured with the accelerator, important one. Which of the following is used to accelerate the vehicle? Accelerator. What is the purpose or function of accelerator? Accelerator, it is either increase the speed of the vehicle or decrease the speed of the vehicle. Acceleration is classified into two types. Two types of accelerations are there. Positive acceleration, negative acceleration. What is positive acceleration? What is negative acceleration? How to define the accelerations, positive acceleration and negative acceleration? Positive acceleration, it is defined as the speed of the vehicle is gradually increased, that is called positive acceleration. If the speed of the vehicle gradually decrease, that is called as negative acceleration. For example, bus away from the bus station, train away from the railway station, so when it is away from the rest position, its acceleration is positive acceleration. If the train or bus approaches the bus station, train approaches the railway station, These are the two types. Negative acceleration, it is also called as deceleration, or it is also called retardation. Retardation or deceleration or negative acceleration all are same. When the object reaches the end position or final position, in that time the object has that negative acceleration. If away from the rest position, that consists the positive acceleration. These are the two accelerations. Acceleration is defined as the rate of change of velocity of the object. Acceleration is equal to change in velocity by time. If the velocity of an object changes from an initial value u to the final value v in time t, then the acceleration a is equal to v minus u by t. It is also expressed like this, del v by del t. SI unit, meter per second square, it is vector quantity. If velocity decreases with time, then acceleration is negative and is called retardation, positive acceleration. If the motion along a straight line and the velocity of the body is increasing with time, the acceleration is in the direction of velocity. Example, the motion of freely falling body. Negative acceleration. The negative acceleration is called retardation. Its direction is opposite to the direction of the velocity of the body. Its direction is opposite direction to velocity of the body. Example, when a body is thrown vertically upwards, its acceleration is negative due to opposing the gravity. Gravitational force is downwards, but object is moving upward direction. This kind of acceleration is called negative acceleration or retardation. Types of accelerations. Uniform acceleration. If the velocity changes uniformly at equal intervals of time, the acceleration of the object is used to be uniform. Motion of freely falling object under the gravitational force of attraction. At every position, gravity remains the same. That is, G is equal to 9.8 meter per second square, or approximately 10 meter per second square. This is small g value. Non-uniform acceleration. When the velocity of object changes at a non-uniform rate, then the acceleration of the object is said to be non-uniform acceleration or variable acceleration. For example, motion of a car in crowded places, or a person who is jogging in the park is acceleration also called non-uniform acceleration. Let us see the equations of motion for uniformly accelerated bodies. Kinematics explain the kinematical equations of an object. The branch of physics which deals the kinematical equations without considering the external forces, that is called as kinematics. In dynamics, we consider the external forces, but in kinematics, need not to consider the external forces. That is the difference. Right. Kinematics, it deals this one. How to write the kinematical equations? Let us see. Object is placed at A. Now, the object, it is displaces from A to B. Initial position of the object is at A, final position of the object is B. Initially, it tries to move with certain velocity. That velocity is called initial velocity. Object reaches the final speed, that is called V. Initial speed is U, final speed is V. It will take certain time period to reach us from A to B. Displacement of the body is S. Acceleration of the body is A bar. Now, total time to reach the object from A to B is T. We know already. For example, total time period to reach the object from A to B is 120 seconds. If you want to know the distance traveled by an object in particular time period, that means in nth second, how much distance it will traveled. Distance traveled by an object in nth second is Sn. So these are the some physical quantities to write the kinematical equations. So what we required to write the kinematical equation? See, initial speed, final speed, displacement, acceleration, time period, nth second, in distance traveled by an object in nth second. So as for these, we will write the kinematical equations. Number 1, V is equal to U plus AT. Second one, S is equal to UT plus half AT square. Third one, V square minus U square is equal to 2AS. Fourth one, Sn is equal to U plus A into N minus half. These are the kinematical equations. V is equal to U plus AT. S is equal to UT plus half AT square. Third one, V square minus U square is equal to 2AS. Fourth one, Sn is equal to U plus A into N minus half. These are the kinematical equations, the object which is traveling along the rectilinear motion. This rectilinear motion is along the horizontal direction only. Horizontal direction. In this case, these are the kinematical equations. Sometimes same kinematical equations now we are applying for the objects which are influenced by gravitational forces. Let us see them. If object is either moving towards the earth or away from the earth, either towards the earth or away from the earth, right? In this, we will write the some kinematical equations. They are V is equal to U plus R minus GT. Second one, here we will discuss the displacement. Instead of displacement, we take the height. H is equal to UT plus or minus of GT square. Third one, V square minus u square is equal to 2gh, either plus or minus. Sn is nothing but hn. Hn is equal to u plus or minus g into n minus half. These are the kinematical equations of an object which is influenced by gravitational force of attraction. Here there are moving towards the gravitational force. Object is away from the gravitational force or opposite direction to gravitational field, same direction to the gravitational field. So for this now we will write the equations. Object is moving or in the direction of the object, an object moving downward direction. Direction of the object is downwards. Gravitational force of attraction also acting on the object downwards. Gravitational forces and object direction both are same. So how to write the equations? Let us see. First one. Freely falling, moving downwards, it is nothing but freely falling object. When object is freely falling, its initial speed is 0. Here, v is equal to u, object is moving downwards, so u plus gt. But object is freely falling, that is why v is equal to gt. Sometimes examiners asking the question, which of the following are the equations for freely falling object, or which of the following are the vertically projected bodies? Which of the following indicates the kinematical equations for the vertically projected body? Like that questions are asking, please concentrate. Second one, h is equal to actual formula ut plus half gt square is there. But here u is nothing but 0. 0 into something, 0. So h is equal to moving downwards, that is why half gt square. Third one, v square minus u square is equal to plus or minus 2gh, where u is 0. So v square is equal to, here value is 0, here which is equal to 2gh. Fourth one, hn is equal to, height in nth second is equal to, u value 0, so g into n minus half. In our examinations, examiner focusing, please focus on it. Next one, vertically projected body. For vertically projected bodies, first one, v is equal to, for vertically projected body, final speed, if object is thrown vertically upwards like this, at maximum height, its final speed will becomes 0. Final speed of the body is 0. So to apply this condition, object is moving upward direction, acceleration a is equal to minus g. Substitute these two. So here v is equal to u minus u, object is moving upward direction, gt, but v is equal to 0, so u minus gt. It implies to u is equal to gt. Second one, Hn is equal to ut plus or minus half gt square, which is equal to ut minus half gt square. Third one, v square is 0. 0 square is equal to minus 0 square minus u square is equal to minus 2gh. Minus minus get cancel. U square is equal to 2gh. Or it is also represented by u is equal to root 2gh. Therefore, finally, Hn is equal to, I am writing here, Hn is equal to u minus gn minus half. These are the kinematical equations for vertically projected body. Okay. See, equations of motion for uniformly accelerated body. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration, and the distance covered by it in certain time of interval by a set of equations known as the equations of motion. V is equal to u plus at, S is equal to ut plus half at square, v square minus u square is equal to 2as. Fourth one is Sn is equal to u plus a into n minus half. We have the another formula where u is the initial velocity, v is the final velocity, a is the acceleration, t time, s is distance. The displacement covered an object in nth second or t second is given by s is equal to u plus half a into 2t minus same, both are same. Sn is equal to u plus here 2n minus 1 by 2, which is equal to u plus a by 2 into 2n minus 1. But examiner taking tth, we are considered nth. All both give the same meaning. Equations of motion due to action of gravity. When the velocity of an object changes due to gravity, the equations of motion are written as v is equal to u plus gt, h is equal to ut plus half gt square, v square is equal to u square plus 2gh, where g is the acceleration due to gravity. When the object is thrown vertically upwards, the value of acceleration gravity g is equal to minus g. Upward direction minus g, downward direction plus g. Right. If both are gravitational force, object direction both are same, downward direction, that is minus g. Equations of motion for an object thrown vertically upwards are u is equal to gt, h is equal to ut minus half gt square, u square is equal to 2gh, sn is equal to u minus g into n minus half. Equations of motion for an object falling vertically. V is equal to gt, h is equal to half gt square, v is equal to root 2gh, sn is equal to g into n minus half. Already we discussed this. Up to here we discussed already.